Hey, this is Steven from LegitTechTutorials, and welcome back to our product design series. We are back designing the automatic spooler module. So we finished doing the dimensional control module. Now we moved on to doing the automatic spooler. So we've just designed the spool, and this one we're going to design to use that spool as well as some of the others. So right now what we're going to do is we're going to design the entire bracket that's going to hold up the spool as well as the pulley. So this design, there's the dimensional control and the automatic spooler. Like I said, the dimensional control is using the force sensitive relays on springs, and on the automatic spooler we're also going to use a FSR. And the reason being is we want to eliminate any error with the spooler. The spooler, as the spool is taking on filament, the radius of the filament changes, which means every RPM of the spool motor will pull harder, will pull more tension and stretch the filament more. So what we're going to do is we just want to keep a constant pull on the filament. So what we're going to do is instead we're going to set a tension on a pulley. So the pulley will be on this module, and then the pulley will allow the filament to also change direction, because the issue with many of these spools is that the spools are too big for the printers, for the filament makers themselves. So we need to have it back up so we can give enough space, because most of those spools are about 8 inches in diameter. So they need to go up. It basically is going to be going up at a 45-degree angle to get the spool farther away from the ground so we can get it on there. And sorry if my cat gets super annoying. Okay, here we go. So what we're going to do is, first things first, is we're going to do our 5/8, and I think that's 0.625 or something like that for 5/8. So our 5/8 hole, and then we're going to undo that. I forgot to change to inches, and we're going to do our 5/8 hole for the pipe, as we've done multiple times already. So 0.625, 0.625. Alright, and then what we're going to do is we're going to do another rectangle, center rectangle, and this one is going to be about 1 inch by, the spools that I have are 2.5, and each piece is a quarter, so that's half. So it needs to be at least 3 inches, so we're gonna do 3.5. Cause it could like hover somewhere in the middle. That's fine. Okay, so now that we got that, we're gonna do a 2-point rectangle, and then what we want here is we are going to want at least 0.75 or so thickness, and this piece needs to be. Okay, so I remember what this is going to be now. So this is going to be like, let's just do 5 inches for right now. But we're going to be changing this because what we need to do is we need to set where the pulley is. So the pulley is going to be set somewhere around this location, but we need to set the pulley towards offset of where the hole in the extruder assembly is. So there's a hole where the filament goes straight down. So we need it to go straight down and, straight across the pulley, tangent to the circular pulley. You need the wire to be tangent to the circular pulley. So we need to add an offset of where exactly the center, the left-hand side of the pulley is, and where the center of the pulley is. So what we're going to do, and then this is also going to set where we 45 off and up to the next portion. Alright, so what we're going to do now is we're going to so the pipe is a 2-inch, and I have a 1/4-inch shim on there. 1/4 inch? I think it's 1/4 inch. So we have a 1/4 inch shim on there. So, because we also want this pulley to be there so it lets the filament go straight through. So it lets the filament go straight through the dimensional control. So we want it to be, now that we're there at this point, you want it to be 2 inches divided by 1, because the hole's in the center, plus a 1/4. So that's 1 and 1 1/4. Should be to the center. So now this is the left side of the pulley. So the filament should come right through this piece, right through this part here. And then we're going to add another portion for the radius of the pulley. And I got my trusty calipers here, zeroing them out. And I think I'm going to do 2 inches, kind of a big pulley. I'm going to do like a 1 1/2 inch pulley. So let's do 0.75. So now there is the center of the pulley. I'm going to do a point here. So here's the center of the pulley. And then we're going to want another 0.75. And the reason why we're going to want another 0.75 is that this is where we are going to angle off. So so we basically want this guy to coincide. So let's see if I could just have it coincide. So this, delete. And I'll put a point. Oops. I'll put a point here, right there. And then this one's going to coincide with this one, like that. Alright, so this is going to be the end radius of the pulley, and then right after the end radius of the pulley, we're going to go off 45-degree angle. This is supposed to be 0.75. Okay, now we need to, this is parallel to that, this is parallel to that, this is parallel to that. Okay. So 75, blah, blah, blah. Then what we're going to need to do is we're going to need to do another rectangle. Doesn't really matter how big it is, because we're going to make this equal to that, this equal to that, this equal to that. Okay. So now no matter what we do here, it's constrained to where it will dynamically constrain everything. Alright, so at this point we are going to stop sketch, and we are going to extrude. And this, we want it to be big because it's going to be cantilevering out the entire piece. So what I mean by that is the entire piece is going to be up here, and it's going to have 1 kilogram, which is 2.2 pounds, pushing down on this guy. Alright, so you've got that. Now what we're going to do is we're going to create another sketch on top. And what we're doing now is we're doing the little tower for the pulley. So now that we got this point here, we're going to project this point, and this point. And then what we're going to do is we're going to do a rectangle, center rectangle from here. 0.75. Okay, so there's the rectangle, and then what we're gonna do, whoopsies, is we're gonna do the same thing on the other side. I think I could have this parallel to that. I haven't tried that yet, but let's see if that works out. Let me do snap to center. Huh. There we go. Now it goes center. Okay. center rectangle, 0.75, 0.75. I mean, that's fine. Okay, so there we go, 2 rectangles. Okay, so now what we're going to do is we're going to, we basically, what we want is we want the pulley to be right in this section here. Right in that section there. And we have a 1.75 millimeter, 1.75 pulley. And of course we could always change this. This will dynamically change to whatever we want. This we're not going to change, but this we could change to the different radius. Okay. So, I used to be able to do this. I don't know why I can't do this anymore. But basically what we're going to do is we're going to extrude this about 1/4 of an inch or so. And then we're going to do a sketch right on the side of this guy. And what we're going to want to do is we're going to come up at an angle, because our printers could print at an angle, if you could remember. So it's going to be like this or so. And then we're going to extrude it forward. So we need to come up with what exactly we want here, because this is all going to be, you know, this is all going to be like hovering, right? So another thing that I could do is I could just, you know, glue the piece on there if I don't want it to do a crazy overhang or anything like that. So what we're going to do is let's just do that for right now, and we'll do that for right now. And then what I'll do here is I'll dimension this to 0.75. Or smaller, have it go to like 0.5 or so. Trying to save filament here. Something like that. Something like that. And then, why is this not closed? Oh. It's just not projecting that geometry. Okay. Then we're going to make this equal to that one. Okay. And then this is going to be equal. Oops. Well, this is going to have to be dimensioned. Actually, well, this we want it to move with what we put here in the center. So I want like a let's do 1-inch blocks then. Okay, so let's just say 1 inch this way. Oh, sorry, 1/2 inch this way, 0.5. No, actually, that sounds okay. 1 inch that way. So we're just going to do a 1 inch rectangle. 1 inch radius that way, and then this be like a something like that, right? Okay. So that's a good idea for right now. Okay, let's go ahead and extrude these back this way, 0.75. Oops. And there you go. There's our shock tower. And then also I remember now that this idea how steep this angle is going to be is how far we want the spring to be, because right now this is a pretty big deal. It's like This is going to give me like an angle distance. That length is 2 inches. Yeah, it's too tall. Long story short, it is too tall. And if we have from like here to there, that is 2 inches that way. This is going to be a little shorter, so that's about a 2-inch spring. That's not exactly what we'll want, but we'll keep that on ice for right now. So we are going to do the same thing again, but we're going to go up here on the front, and this is where we're going to do the side angle that's going to come off here. So let's go ahead and do, and we don't want anything, we want to keep it about 45.45. I mean, we could go, oops. We could go 60, but 60 is really pushing it. And then we want to gain, no, maybe like 4 inches or so for right now. Let's just do that. And then want this coming straight off. Or, actually, no, I don't care about that for right now. This, let's put that down there. And this, we're just going to leave arbitrary right now. This is parallel to that one. Okay, so this is going to be enclosed here, and then what I'm going to do is I'm going to make a little tower piece. Straight up here. So let's do this 0.75. Is that snapping? No. Why would I do that? Whatever. Okay. And so now what I'll do is just, oh well, this is supposed to be parallel. So let's just have this. Here somewhere. Okay. All right. And then we'll just start another sketch on that other side. And then we'll just project this sketch. Okay, then this is going to be 0.75. Oops, negative 0.75. Alright, so there is our tower. As you see, it might even need to be thicker than that, because right here it's very thin. Very thin. So what we could do is we could have it go big and then come up at a lesser, steeper angle. So right now, because that's going to support 2 pounds, and that's cantilevered out, that's a lot of torque over here. It would be cross product of torque, blah blah. So project that, pound include, pound project include, boom. There's that. Okay. Well, I mean, there you go. .75, and then there we go for that. So this is definitely going to need to be adjusted as far as the strength that this does, because this is way too weak. I mean, you can't just go like everything here across. It'd be nice if we had something that goes here and across, and like here and across, where everything's hovering. The only thing that we could do is we go here, down, and across. Which, I mean, is fine with me. To go from here, down, and across. That's a good idea. Maybe I'll add to that sketch there. So we're up at 20 minutes. Let's add any other things that we need. I mean, this is the main thing that will be changing, so I'm not finalizing this too much. But what I'm going to want to do is I'm going to want to definitely edit a few things. Get this for the center. So here what we want is we want it to also have a circle for a rod that goes outside, and then we're going to need some sort of bracket for the motor. And the bracket's probably going to have to keep coming up at a 45-degree angle in order to print it correctly. So there's going to be another piece up here, like high up here, that will be the motor. So let's go ahead, and that's only going to be on one side. We only have the motor attachment on one side. So yeah, let's go ahead and let's draw that. So there'll be a piece coming off here, and then this is going to put a lot of torque. And this is going to have to be continuing off at 45 degrees. And this is going to come off 45 degrees. No. It's going to have to come off from like over here at 45 degrees. Actually, now that I think about it, theoretically speaking, the motor I'm going to get is circular. I know that I pretty much already have the motor. So the motor here is going to be circular. So we might even change this particular side to a circle and the other side to a square. But right now we're going to leave this as it is. What I am going to add is I am going to add a small circle in the center. So what we're going to have is, again, we're going to have another bearing. So hopefully like a 2-5 inner circle. So there's going to be a hole all the way through. And then so let me explain a little bit how it's going to go down. I like how it just projects the entire sketch. That's pretty good. I didn't think it was going to project the entire sketch. Okay, so what's going to happen with this guy, as we are running out of time, is there's going to be a spring here. So there's going to be like a little cone, which we'll draw in a later piece, which basically it'll have like a rubber. It'll have like some sort of high static friction coating on it. So rubber or some sort of plastic that really has good friction on hard plastics like ABS. So like I said, high static friction on hard plastics like ABS. So rubber, cloth, whatever, is going to be like a cone. It's like a cone shaped, and it will basically be shoved inside of these holes, and then that will be its drive. And I was originally thinking about like a little pin that goes up here to drive as well, but not every single spool has that. There's a whole bunch that don't have that. So what I'm going to do is I need to get all my driving force out of just two cones pressing into each other. So there'll be a cone here. There'll be a cone here pressing into this side of the spool holder, and a cone here that presses into the side of the spool holder. And it basically will hold it from both those sides, and then one side will turn. So this side will turn. This side will turn the cone, and this side will not turn the cone. This side will just act as a bearing, but it will hold it they will hold it together. So hold it in the center. So we want them both to be in the center of the of this guy here. So hopefully they both hold center correctly. Or another thing would be that you have to just like ratchet one side or whatever. But yeah, mainly we want them both in the center. So there'll be a spring here on this face, right? And then there will also be a spring here on this face that presses those two cones into the sockets of the spool. And because they're springs, in order to take the spool off, you just have to like press on one side until the spring bottoms out. So another thing that I could do is actually just have one side springed. That's actually a better idea. So this side, well, if you do springed, you could set how it. You could set the spool size. But most spools, like I said, are really close size, and it's okay if you're off like a quarter of an inch off center. That's fine. Or even 0.10 off center, because the difference between each is like 0.10, so you're 5/100ths off. So that's fine. 5/100ths of an inch is not a big deal. So like I said, spring here, pressing on this face with a cone attached to a cylinder that would be attached to a bearing in here. So there'd be another bearing riding in here, just like we had on the rollers, so that this guy could spin really freely. And then on this side will be our motor. That's a circular motor, high torque, gear reduction motor, and it will turn that cone, that rubber coated cone, that fits inside the holes of these spools and force them to turn. So let me see if I can put a spool in front of you guys in order to visualize what I'm talking about here. So here, let me find a different one, like this. No, it's really small. Here we go. Okay, this is fine. Okay, so a hole like this, so there'll be a cone that will fit, that will be a universal cone, and will fit to have a particular angle to it that'll fit in every single spool that you throw at it. So there will be a big cone that shoves its way in here, and then the rubber will grab onto this ring here. And then same thing with the other side. And then the rubber will force this guy to turn and keep tension on it so it pulls. And then so there's a lot of force that's going to be pushed onto that small little lip of that spool in order to get it to turn. So a few more things that we need to design on this guy. We'll see if we could what we could do with it. We'll create oopsies. What is this? I don't know what that was for. There we go. So let's go ahead and see what we could do here. I'm not exactly sure what I'm going to actually do with this, because it has what was it, 3/4? Is a 3/4 circle, which doesn't really work out because we don't have actually no, it's a 1/2 inch circle. It's a 1/2 inch circle, I believe. It's over there on my table. I don't want to grab it for right now. Yeah, it seems about right. It's about 1/2 inch. So we're gonna add an offset. Um, 0.05. that's fine. And then we're going to need to cut that hole in it just like we did before. And then this is going to be the circular perch. So let's go ahead and get that guy like that. And then get it out. Tenth of an inch or so. Alright, this is good. And then the FSR is going to be in there. So one thing that we could do to check really quick is this guy. And we could look at that last sketch. Okay, so it was 0.75. So we're going to need to change that because we could no longer do any sort of we can no longer do any sort of offset here because this wall is already 0.75. Alright, so a few situations that we're going to need to change. One thing that I'm just curious about, that I'm going to show you guys what I do. Oh, we have a whole bunch of bodies in this. Oh, no, we don't. Okay, so what I'm going to do is I'm going to change this physical material, because I'm curious about the weight that this is going to be. So let's just do ABS plastic, white ABS plastic. And if we want to, we could change it back to steel. Steel's that grayish color. So right now, ABS plastic. And then ABS plastic is slightly off as far as the density. ABS is about 1 gram per cubic centimeter. And so what we'll do for right now is we'll change this to centimeters. Reason being is that we can now check the, what was it here? And then you go to properties. And then here you go. So we have density 1.06 grams per cubic centimeter, but in PLA it's 1.25 grams per cubic centimeter. So let me just close this. Okay, so our mass is so we'll just multiply this by 1.25. We'll just forget about that 0.6. It's 208.117 multiplied by 1.25. So that's about 260 grams, plus or minus. I mean, what you could do is you could do. My cat's freaking me out. So 260 grams, let's just say 240 grams or so, or 235 grams. Yeah, let's do 235. And then we're going to multiply this by about, the density I'm going to do is about, or the infill I'm going to do is about 15%. So let's do that by 25. So that's about 58 grams. So I could print what, 20 of those? Well, I could only print less than 20 because it's 8 grams, but I could probably print 17 or so of these in a kilogram, so I like that weight. That's a good weight. And if we look at this guy as well, oops, the same way that I was showing you guys, but this has a whole bunch of bodies. These are just two separate ones. So this is also ABS. But we want to change this to centimeters. And then go back. It's body 2, main body. Properties. This is 103 grams. So this one is definitely, it's 120 grams or so times 15. 120 grams multiplied by 0.25 or so, which is this is only 30 grams. So the other one's almost twice as much. So we could also optimize this for weight, because this guy is going to be super heavy and use quite a bit of plastic. Alright, so that is going to be it for this video. This is going to be the main piece that we're going to be manipulating to work with whichever motor we buy, and it's definitely going to take the most time to get right. So this is just a little rough out video to take a look at a few things that we need to keep in mind. Alright, so this has been Steven from LegitTechTutorials. Thank you guys for watching. If you like this video, please subscribe for more videos like it in this series and other series as well. I will see you guys in the next video. Take it easy. Have a good day.